Here's a question that keeps people up at night. Is the future already written? Is your life just following some predetermined script, or are you actually creating the story as you go? And you might think that's just a question for philosophers, but it's actually a deep and ongoing battle right at the very heart of physics.
For centuries, this has been the ultimate question, right? Are we all just actors playing out a script that's already been finalized? Or does genuine, unpredictable chance actually exist in the universe? To even begin to find an answer, we have to figure out which laws of physics are telling us the whole story. So let's start our story a few hundred years ago. Back then, there was this really powerful and honestly a pretty comforting idea: the vision of a clockwork universe. A cosmos that was elegant, it was orderly, and most importantly, it was completely predictable.
Now, this whole vision is built on one huge concept: determinism. The idea is simple, but when you really think about it, it's kind of staggering. It says that if you could know the exact position and motion of every single particle in the universe right now, you could, in theory, calculate the entire future. And not just the next solar eclipse, but every event, big or small, that will ever happen. And this idea really took off with classical mechanics, mostly thanks to Isaac Newton. His laws of motion and gravity painted this absolutely stunning picture of the universe as a giant, intricate machine. Every planet, every star, even a falling apple, it all followed these precise, unbreakable rules. The whole cosmos was just a grand clock, ticking away with perfect, predictable regularity.
This was the core belief of that whole classical viewpoint. The universe was seen as this incredibly complex puzzle, sure, but it was one that could, in principle, be completely solved. No surprises, no real chance, just the elegant unfolding of physical laws from one single starting point.
Okay, but hold on. Real life feels a lot messier than that, doesn't it? If everything is a perfect clock, why can't we even get a reliable weather forecast for next week? This seemingly simple question points to the very first major crack in that perfect deterministic dream.
And this brings us to chaos theory. Now here's the twist. Chaos doesn't actually get rid of determinism. In theory, a system like our atmosphere is still 100% determined. The problem is a practical one. It's so incredibly sensitive that the tiniest, most unmeasurable difference, like the famous flap of a butterfly's wings, can cascade into a massive hurricane weeks later. So yeah, the determinism is there, but perfect prediction becomes practically impossible.
So chaos theory put a crack in the clockwork model. It made perfect prediction impossible in practice. But the next scientific revolution, oh boy, it didn't just crack the model, it took a giant wrench and completely shattered it. Things were about to get fundamentally weird.
In the early 20th century, physicists started poking around in the strange world of atoms and particles, and the old rules, they just stopped working. What they found wasn't a smaller version of the clockwork machine they knew. It was something else entirely. The arrival of quantum mechanics didn't just change the equations. It changed our entire idea of what reality even is. Just look at the difference between these two worlds. It's staggering. The classical world was a clock. It was certain. It was objective. The quantum world, on the other hand, is like a roll of the dice. We can only predict the probability of an outcome, never the certain result. And even stranger, reality itself seems to depend on whether or not we're looking at it. All of a sudden, the universe wasn't built on certainty anymore, but on fundamental, can't-get-rid-of-it chance. Now, you can imagine this radical idea of a random universe was deeply unsettling to a lot of physicists, including Albert Einstein, who famously said God does not play dice. So a bunch of them immediately started searching for a way to explain away all this randomness and somehow restore that old, comfortable deterministic order.
And this led to the central question of the whole debate. Is this randomness we're seeing a true feature of the universe, or is it just a reflection of our own ignorance? Maybe the universe isn't really rolling dice. Maybe we just can't see all the information we need to predict the outcome.
So this gave rise to a clever idea called hidden variable theories. The thinking goes something like this. Step 1. Okay, quantum mechanics looks random. Step 2. But what if there are secret properties, these hidden variables, that we just can't measure yet? And then, step 3. If we could just access that hidden information, all the seeming randomness would disappear, and the universe would be shown to be perfectly predictable once again. Determinism would be saved.
For decades, this was purely a philosophical argument. It was just back and forth, with no way to prove it one way or the other. But then, in the 1960s, a brilliant physicist named John Bell figured out a way to take this philosophical question and turn it into a real, honest-to-goodness physical experiment.
Okay, the details are super complex, but the conclusion is just staggering. Bell proved that if there were hidden rules that were also local, which basically means nothing can influence anything else faster than the speed of light, then the results of certain experiments would have to follow a very specific pattern. But when those experiments were done again and again and again, they violated that pattern. The universe behaved exactly like quantum mechanics predicted it would. It was an absolutely devastating blow to the idea of a simple, hidden clockwork reality.
So if the simple, local hidden rules are out, where does that leave us today?
Well, the debate is far from over. It's just that the leading theories have become even more strange and mind-bending than ever before.
Today there are two main views competing for the top spot. On one side, you have the more traditional Copenhagen interpretation. It basically accepts the weirdness and says, yep, the universe is fundamentally random. It really does roll the dice. But then there's the many worlds interpretation. Now this one saves determinism, but at an incredible price. It suggests that every single possible quantum outcome actually happens, each one branching off into its own parallel universe. So in this view, the overarching multiverse is deterministic, even if our own path through it feels random.
So, after all that, where does this leave us? Well, with the profound realization that the most fundamental level of reality is still deeply, deeply mysterious. That ancient debate between a determined clock and random dice is still raging today, and physics, for all of its incredible power, has not yet given us the final answer.
Which leaves us with one last incredible thought. Is this life you're living the only one, shaped by genuine, real chance? Or is it just one path through an infinite multiverse where every other choice you could have made is being lived out right now in another world? Physics can't yet tell us. Thanks for joining The Explainer.